In this lesson, we're looking at classifying compounds, specifically metals, acids, and organic compounds. First, let's go through and define these different types of compounds. So metals, we can see on the periodic table that I've drawn here, and they reside in this kind of striped region, which is all the way from the left-hand side of the periodic table to the right hand side staircase. And that's usually the staircase we look at between metals and nonmetals. And it's usually marked on those periodic tables. The organics all contain carbon. They also often contain hydrogen, oxygen, phosphorus, chlorine, nitrogen, and many other species. They occur naturally in nature. And have a carbon backbone. That means their structure is made primarily out of carbon. It has other atoms to kind of supplement it. Lastly, we have acids. Acids are any molecule with an H plus ion or a proton to donate. Not all hydrogens are donatable. So you have to look a little bit deeper into that. We're going to look at that here in a second. The main reason that not all of them can be donated is some hydrogen are more tightly bonded to other atoms. So now we're going to go through some example problems, just classifying some compounds. So our first compound is iron, which has the atomic symbol Fe. And if we look at it on the periodic table, we can see it's in the middle there in our transition region, which we have marked on our periodic table up here in this shaded region. So therefore, since it's in that region, it also doesn't contain carbon and it doesn't have any protons. We know it must be a metal. Next, we have CH3COOH. Now looking at this, we have a carbon backbone here with two carbon atoms. So it could be organic. It also has lots of hydrogen here. It could be acidic. But it doesn't have any atoms that come from the metal region. So therefore it's not a metal. And it falls into the organic compound category just because we know that it has that carbon background. But now we have to determine if it's also an acid, because you can be both organic and an acid at the same time. So when we look at this, there's two different types of hydrogens here. We have the hydrogen bonded to this oxygen over here, And then we also have all these hydrogens bonded to this carbon. So the main thing we want to look at here is the structure. If we do remove the hydrogen, how stable it will be. Well, carbon is really unhappy if we take away one of its bonds. It really likes to have 4 bonds. So we don't take away these hydrogen. They're too tightly bonded. But the hydrogen over here is just bonded to this oxygen. So if this hydrogen comes away, we'll have H plus. Then we can have resonance bonding, if you know what that is. So we'll have 1.5 bonds on each of these oxygen. So resonance allows the H plus to be donated, so it's also acid. Okay, now let's look at the next one. So we have butane here. And looking at it, we can see that it doesn't have any of our metal atoms. So no metal atoms. So it's not a metal. It also doesn't have any hydrogens ions that we can donate. Because they're all bonded to carbon, which doesn't give up hydrogen for the sake of acids. But it does have the carbon backbone. And hydrogen, which leads it to be organic. Next we have HCl. This one we don't have any metal atoms. We also don't have any carbon. So that rules out organic and metal. And we do have an H to donate, the hydrogen here. So this is very acidic, hydrochloric acid. It's very common. So it's an acid. Next we have barium, Ba. So if we look at it on an atomic or a periodic table, we'll see it resides in the shaded region that we made for metals. So if we look at that, it's just going to be a metal because we know there's no carbon or hydrogen once again. Lastly, we have urea. And looking at urea, we see that we have one single carbon, we have nitrogen, hydrogen, and oxygen. So we know automatically it's not a metal. It doesn't seem to have a carbon backbone, but we're just kind of leave that at this moment. And the hydrogens on the nitrogen aren't really in a position to be donated. So there's no H plus donations. Has carbon, oxygen, nitrogen, and hydrogen. And therefore that leads us to classify it as organic. So using these kind of key factors for each of the groupings, you can classify these compounds and many other compounds like.